Welcome back to my channel. Today in this video we'll be solving this question, number of longest increasing subsequence. So given an integer array, return the number of longest increasing subsequences. Notice that the sequence has to be strictly increasing. So I hope you guys know already about the what are subsequences and what is the longest increasing subsequence. This is kind of a basic thing. So I'm not going to explain here. So let's try to look at this example 1355547. So there are two longest increasing subsequence here. The first one is 1347 and the second one is 1357. So let's see the constraints. Num set length it's of 2000 only. Okay, and the number can be in the range of minus 2, yeah, minus 10 to the power 6 to 10 to the power 6. So let's look at this example 2 also. We have 2 2 2 2 2. Okay, yeah, like we have 5 2, and according to the question the sequence has to be strictly increasing, so I cannot take a subsequence like 2 2. Okay, it is not a strictly increasing subsequence. So what is the longest increasing subsequence you will find here? It will be the of length 1. So how many are there? How many subsequences are there which are of maximum length? So there are 5 subsequences which are of maximum length. That is 2, 2, 2. Okay. So they are like this. So let's see how we are going to solve this question. I will just I will just first explain you the algorithm. Then you will get it what I am doing. Okay. So let's see this one example 1355547. Okay, 13547. Let's create two tables. One is DP. Okay, and another one is count. I will tell you what they represent and what they will what information they are going to provide us. So DP at ith index will give me the longest increasing subsequence, the length of the longest increasing subsequence using that nums of ith element. Okay, so suppose I am at this 5, it will tell me what is the longest increasing subsequence I can make using 5. Okay, this is what it will tell us. So yeah, initially, what is the length of the longest increasing subsequence with zeroth element? It will be 1, which is 1 himself only. 3 it will be what? 3 himself only. Okay, so DP table will be filled with all 1. So let's understand what is count. What does count table represent? Count table basically represents the number of longest increasing subsequence at that index. So what I have written is that see here what I have written at DP of second index and third index, like 0 1 2. Okay, only 0 1 2 3 4. This third index what I have written, it's 1. I will now count of second will represent the number of subsequences which are ending on this index, and what is the count of that. So the count is initially just 1. Why? Because 5 it itself will be uh, the count. Okay, so there will be just 1 present in each and every indexes of count. So now let's try to understand what we are going to do. Okay, now, so let's say you are, what I am thinking of doing is that, now let's say you are at this position. Now what I am trying to do is that I will go start from the very left and I will check, can 1 be with 3? And for that what I will simply check is that if nums of previous index, I mean the previous index which I am starting from 0 till the ith guy. Okay, I mean this guy, not up to here, but one lesser than it. Okay, so if nums of previous index is lesser than nums of I, then I can this can be a subsequence. Okay, this can be a strictly increasing subsequence. So now after this condition is validated, so let me write, if nums of p index is lesser than nums of I will check is. So what do you want? You want the longest increasing subsequence, right? So you will make sure that if you are taking this one, if you are taking for three, if you are taking one, this should contribute to your answer. I mean, initially, if I had a longest increasing subsequence LCS of length 1, then either it should be of length 1, I mean, the if I will combine 1 and 3, or it should be greater than that. Okay, y equals to, I will explain you while we begin, while we will be, as we go through. Okay, so I hope you understood why I want greater. Like initially, see, if initially, what is initially at first index? It's 1. I have a length of just 1 at this index. So I will check if 1 plus dp of p index, dp of p index will give me what? The length of the longest increasing subsequence ending at this position, right? So it is 1. And I added 1, why? Because I will be adding 3. So if this operation is greater than the dp of I will say what? I will say now update the dp of I, because I have found a good answer. So I will say dp of I is equals to 1 plus dp of p index, and at the same time my count variable will be updated also. Now let me give you an example. Suppose I have this test case. Okay, let's say 213 and it's a 5, right? So at 3 I can make what? I can make a subsequence of length 2, and that will be maximum. The first will be 1 comma 3 and the second will be 2 comma 3, right? Both of them are of length 2. Now let's say I want to get the answer for 5. I will check, can 3 be my second last element? So yes, it can be, because 3 is lesser than 5. So now I'll say update the dp table. At the same time, if you see, I have two choice. I mean, there are two longest increasing subsequence adding at ending at 3. So what will be the longest increasing subsequence and ending at 5 if I combine 3? So it will be 1 3 5, right? And 2 3 5. So my count of I will be updated how? It will be count of previous index, whatever is the length, whatever is the number there, whatever is the number of longest increasing LCS there, it will be that only. Okay, right. So this is what happened, and at the same time, it might happen that the 1 plus dp of index is not greater than dp of I, but equals to dp of I, right? Equals to dp of I. So I will check for that as well. So let me write it. dp of index is equals to dp of I. So why I am considering this option? Let me give you a test case so that I can try to explain that. Okay, I am trying to explain you that. So let me think of an suppose I have a 5 here. I have got a some number, right? I like it was 213. So at a 5, I have some numbers here also. Let's say 4. Say now just initially just think of this one. Okay, I have at 5. What I can make is this 135 and 235. I can make. Now suppose I found that uh, while checking this statement 1 plus dp of previous index is greater, I mean sorry, while checking this if statement, this statement occur true. Now secondly I will check what if 1 plus dp of previous index is equals to dp of I, which means that if I am going to add 4, I mean, let's say we are trying to check 4 and 5. Okay. I found that 4 is lesser than 5. Okay, cool. Now I'll check will adding 4 will give me a better result than my current one. And currently I am having what? A length of 2. I'm sorry, length of 3. A max LCS of length 3. So now I found that, and at 4 I have, let's say I have uh, let's say 2 2 4, ignore the 3. Okay, I was just giving you example, and let's say 1 4. So now I found that adding, and what is the length of it? It's just 2. 1 plus dp of previous index, p index is this. What is the length of the longest subsequence here? It's 2. Is it equals to the length of the dp of index, which is 3? If it is equal, then it might happen that my 3 is the maximum length of the maximum LCS. Okay, so I need to add the answer because I want the number of longest increasing subsequence. So if 3 is the longest LCS, okay, if 3 is the LCS, so I should add the count. Okay, I should know about it. What are the So what I will do here is that I will try to add. I'm not going at this position. The dp of I is not going to update. dp of I is not going to update. Why? Because I haven't found anything greater than that. But what I have found is that the LCS which are ending at that previous index, and if I will combine that with my ith element, they are going to form a longest common subsequence of exactly the same length which is initially right now. So what I will try to do is that I will try to add the count of it. How many LCS I have found at the P index. That is what I will try to add to my current value. So count of I will be updated like this. Count of I equals to count of I plus count of P index. Simple, guys. So during this process I have to make sure that I am uh, checking out, I mean, what is the maximum length I have found till here. And at the end what I'm going to do is that I'll simply suppose the maximum length found is 3. Okay, now it might happen that I want to know how many LCS are there, right? So what I have to do is that I have to go at each index of, count, and I will be checking each index. And if I found the dp of I is equals to the max length, then I am going to add count to my answer, right? So let's try to solve for this, and you will get it very clearly. Okay, so 13547. Okay, so initially we will be checking for this. Okay, I found 1 is lesser than 3. So if 1 plus dp of previous index, which is dp of previous index is what? This one. 1 plus 1 2 is 2 greater than dp of I. dp of I is what? 1. So is it greater? Yes, it is. So dp of I will be 1 plus dp of previous index. So 1 plus dp of previous index is 2. Okay. And count will be also updated. Count of I is equals to count of previous index. So count of I is this location and count of previous index was also 1. So it will be same. Now I have solved for this, right? If you check dp of I, then the maximum LCS I can make uh, is of length 2. Okay, which is 1 in 3 only. So now I will do for 5. Now I will check, can 1 and 3 be 1 and 5 be the a combination? So yes, it can be because uh, 1 is lesser than 5. So now I will try to update. If so, let's find what is dp of previous index and dp of index. I will write down as we go through. I will write down each and everything for a for that particular value. Okay, so dp of I here, what is dp of I, and at the same time count of previous index and count of I is what? Okay, so now what is my previous index and say what is the dp of previous index? It's 1. dp of I is what? dp of I is also 1. Count of p index 1 and 1. Now I will check if 1 plus dp of index, dp of p index, dp of p index is 1, 1 plus 1 2 is greater than dp of I. Let me write this one. Well, 1 plus I can let me write it here only. 1 plus dp of p index 1, is it greater than dp of I, which is 1? This is 2 is greater than 1. Yes, correct. So let's substitute the dp of I table. So now dp of I will be what? 1 plus dp of index. It will become 2. So let's change here also, right? And at the same time change count I also. So count of I is equals to count of previous index. So there will be no change here. Okay. So what 2 represents is that I have a length of 2 ending at 5. Okay, which is 1 and 5 only. Now I will go to 3. So let's write the dp of p index. P index represents previous index. dp of p index is 2. dp of I is 2. Count of previous index is this. Yes, correct. Now I'll check, can 3 be a part of this? I mean 3 is lesser than 5. Yes. So now I'll check 1 plus dp of index, is it greater than dp of I? So 1 plus dp of previous index, which is 1 plus 2, is it greater than the dp of I, which is dp of I is what? 2. So 3 is greater than 2. So yes, this can be a, so this can be a match, right? I can add this. So if you see at 3, what is the length of the LCS? Okay, it is 2, and 1 and 3 was that. Okay, I mean 1 and 3 was the LCS. Now if I will combine, then it will be 135. That's cool, right? So now dp of I will be what? dp of I will be 3. 1 plus dp of p index. dp of p index is 3. At the same time count will be what? Count of I equals to count of p index. So it will be 1 only. So now I am done for 5. I will do this for 4. So for 4. So similarly, this will happen for 4 and 7 also. And at the end, what I have to do is that I have to go through all the indexes, and if I find the maximum length is equals to the dp of I, then I am going to add the count to my answer. And at the last, I will simply return it. So now let's move to the coding part. int, let's say n equals to nums dot size, right? I have to create two tables. One is dp of size n, and everyone will be filled with 1. If you will do dry run now, guys, you will easily understand it. I mean, you will get most of it. Dry run is very important. So let's say max length is equals to 1 initially, because 1 will be definitely the maximum length in the worst case. Okay, so let's take that. So now I'll say int I is equals to 0, I is lesser than n, I plus plus for int previous index is equals to I, and previous index will go up to where? Lesser than I. So I'll say pre index plus plus. So if I find nums of p index is lesser than nums of I, so this can be a valid match. I mean, I can attach the previous index element to the ith guy. So I will check now if matching them gives me a better answer or not. It's like this. So dp of p index is greater than this. Okay, p index is greater than dp of I. If it is so, I will say update my dp of I with 1 plus dp of p index, because I have found a greater value. So yeah, now at the same time count of I will be also updated. This will be count of p index. Else if there can be second thing, that is the 1 plus dp of p index is equals to dp of I. And what we are going to do at this is that I want to know the because that the current 1 plus dp of p index, or let's say dp of I, they both are equal. This value can be the maximum length. So while traversing the every element, traversing the array at the end, it might happen that this dp of I is the maximum length. So I need to find the answer, right? I need to know how many of them were there. So I will simply add the count of it. I need to add the count of it. Okay. See, the thing is that it is not contributing to the length of the longest common subsequence, but it is definitely contributing to the count of the length of longest common subsequence. The count of that is increasing. Okay, so I will say count of I equals to count of I plus count of previous index. Now I have solved for the ith guy. I will check what was the maximum length you found here. What was the maximum length LCS you found here? So max length is equals to max of max length comma dp of I, right? So this is what I have to do. Now at the end, what I'm going to do is that I'm simply going to add. I'm going to check if this guy is forming the LCS, maximum LCS. So I will add the count to the answer. Okay, so let's take an answer variable. Int I is equals to 0. I will go up to end like this. If I find that dp of I is of max length, so I will say answer plus equals to count of I. I need to know count of what I represents what. What does count of I gives us? Count of I will give the number of LCS ending at ith element. So return it. What is the time complexity, guys? Time complexity is just O of n square, and space complexity is O of n, because we are dealing with this vector, okay, which is of size O of n. So let's run this. Let's try to submit it, guys. Cool. The answer is submitted. Okay. So I hope you guys understood the solution. Thank you for watching the video.